Some runners take tablets to help muscle recovery after long races. These tablets contain magnesium oxide. A student wants to find the percentage by mass of magnesium oxide in the tablets. Magnesium oxide reacts with hydrochloric acid to form magnesium chloride. And they've given us the equation. In an experiment, the student adds excess hydrochloric acid to some tablets, then does a titration using sodium hydroxide to find how much acid is left, and they're giving us another equation. So what they're saying here is that they've put in a big bunch of hydrochloric acid in excess. All of this is our hydrochloric acid. They've used some of it to react with the magnesium oxide, and the rest of it they've reacted with sodium hydroxide, but the total amount will be what's reacted with both. How did they do it? They placed a beaker on a balance and recorded the mass, add 6 tablets to the beaker and record the mass again, add 25 centimetres cubed of 2 molar hydrochloric acid, and stir until all the magnesium hydroxide has reacted. So this number here, this 25 centimetres cubed of 2 molar, that is 0.05 moles. That's how much hydrochloric acid we put in at the beginning. They then put the mixture into a 250 volumetric flask and made it up with distilled water, and used 25 of this in a conical flask with the suitable indicator, 0.09 mole per decimetre cubed sodium hydroxide, and they've given us a mean titer here. So they've put this leftover hydrochloric acid into a 250 flask, used 25 of it, and then titrated it with 0.09 mole per decimetre cubed NaOH, and they've needed 20.38 centimetres cubed to neutralise the hydrochloric acid that's in here. Remember, in that hydrochloric acid came from here, and this was the hydrochloric acid that is in this bit here, the leftover part, the part that didn't react with MgO. I've got the mass of the tablets on the balance for us here. Each reading from the balance, so let's go back, each reading, record the mass, 2 readings times 2, has an uncertainty of 0.005, 2 of those, and it was in the balance for measuring the mass, the 2.14 grams. So you want to type that into your calculator. So again, my advice is use that fraction button on your calculator, type it in as it looks, and I'm getting 0.467%. Calculate the amount of moles of hydrochloric acid that was added in step 3. Well, actually, if you look, I did that at the time. So this was the number of moles of hydrochloric acid in total. So this was our 25 centimetres cubed of 2 mole per decimetre cubed, so 0.05 moles. Oh, they've already written moles on the line. Use your answer to question 7.2 and the information given to calculate the percentage mass of magnesium in the tablets, magnesium oxide in the tablets. So we need to go back and start here. Just did not mean to delete that. And start here with how much sodium hydroxide did we use in the titration. So let's start there. So we can calculate the number of moles of NaOH, which was our 20.38. Let's put it into decimetres cubed and times by our concentration. So you want to do that on your calculator. It's coming out as 1.8342 times 10 to the minus 3. Now if you go back and look, that was the number of moles used in the burette. To link it to the number of moles in the conical flask, we need to look at the ratio. And the ratio was 1 to 1. So if the ratio is 1 to 1, the number of moles of HCl in the 25 centimetre cubed conical flask is the same. We need to be careful now before we do the subtraction, because that HCl came from the volumetric flask. How many 25s are in 250? How many more moles of HCl are in the volumetric flask? And this was everything that didn't react with the magnesium hydroxide, went into the volumetric. Well, there's 10 25s in 250. So type that on your calculator and you get 0.018342 moles. So if we go back and have a look at our little diagram, in step 2 we added this 0.05 moles of HCl, and then we used it with the magnesium oxide and lots of it went away, and what was left went into our volumetric flask. We've just worked out that this bit is 0.018342. So what's this bit? So it's a subtraction. So this would be the number of moles of HCl reacting with the MgO. So 0.05 is all the HCl minus what was left to react with the sodium hydroxide. That's 0.031658 moles on the calculator. The question is not actually about HCl, it's about magnesium oxide, so scroll back again. We've got the number of moles of HCl and we want the number of moles of magnesium oxide, and the ratio is 2 to 1. So using the balanced equation, the number of moles of magnesium oxide equals the number of moles of HCl divided by 2, because the ratio is 2 to 1. So if we do that on our calculator, we get 0.015829 moles. So the question is, what's the percentage by mass? So let's work out the mass of magnesium oxide. Now mass is Mr. moles, MR times moles. So you want to add up the MR, so 24.3 adds 16, so 40.3, and times it by the moles. That's 0.638 grams. And then we want to express it as a percentage of the tablets. There's 2.14 grams of tablets. And that is coming out as 29.8%.